Hi, good morning, and welcome to the ZP vlog and podcast. So we'd like to do this at 8 a.m. every Sunday, and it's just really a wrap up from the news from ZP for this week. I'm going to jump into it essentially now, and just say that this week we have been putting a bit of an emphasis on something called Vault Deposit. I will cover Vault Deposit. I want to say a lot. And what I mean by a lot is that Vault Deposit is a robotic system with an AI brain that can do multiple or parallel electrodepositions, electropolymerizations, electroanalysis, and it really lends itself to material science. So I will come back to that shortly because I do have quite a few. We do have quite a few notes on Vault Deposit this week. Something that we do every Thursday at 8 a.m. London time is we do our ZP Developer Zone webinar. Questions come in to us, and we like to sort of answer the questions in that webinar. And things that we've kind of covered this week are questions around electronics, around sensors, around Ginger. So every week, as I say, we do deal with questions that come in from the ZP Developer Zone, and we do answer them in a weekly webinar. Something else that we've done this week as well is we do have these workshops. So every Thursday, every second week of the month, we do like to do a workshop. We have people come in. Now, when I say every second week, we often do a workshop in Norway in the first week of the month, and we do a webinar. We do a workshop in the second week of the month in Coventry. So we were delighted to have people attend our workshop this week. Everyone got to make a biosensor, and everyone got to sort of learn a lot of theory and also a lot of sort of real world applications of biosensors as well. So thank you to the attendees for coming to that workshop. This was something that did come out of our webinar this week. We did do this webinar, as I say, on Thursdays at 8 a.m. London time, and we do like to sort of answer questions that have come in during the week. And one of the questions that had come in was really about the testing of Ginger and Ginger products. And it was kind of interesting actually because when we were testing these products, we did find that we were actually recording the ginger in much higher concentrations. Sorry, I should say the gingerol in much higher concentrations than they would have otherwise expected. But we found this actually across a couple of different vendors. So it was kind of interesting that both vendors gave us products. The vendors' results came out quite the same. And one of the products, we actually hit the value that they were expecting directly on, but in a lot of the products, we were actually recording it higher than they expected. Now, the nice thing is we do get to see our raw signal, whereas a lot of the time with this kind of food analysis, people get to see like a certificate of analysis that comes from a sort of third-party analytical lab. But they really, it's a trust thing. I understand that, and there's a quality system in place, but it literally is trust that, what they're being shown on that certificate of analysis is accurate. And you could argue that that's actually an assumption. And I think with our gingerol testing, that is proving to be the case. Now, I said I'd come back to Vault Deposit a few more times today, and that's why I didn't want to bear on it earlier on. But what's nice about Vault Deposit is it's really, because of now the capability of having it's essentially a robot which can take up to 50 working electrodes at a time, upon which we can do sort of depositions, and then we can also do analysis. Because it's a robot, it's able to kind of come into solutions. We're able to deposit onto those electrodes, and then, for example, we can move to a test solution and do like the hydrolysis of water. So we could do like a sort of deposition of electrocatalysts on the electrodes, and then move to a solution where we then did the electrolysis of water and just see how efficient that new catalyst was. Now, these channels on this robot are actually independent of one another, so it can really vary the way we do that deposition. So you can sort of have the variables on the input can be the materials themselves, but it can also be the process of deposition itself as well. And it can also be the way that you use the material in the hydrolysis, for example, as well, can also be a variable. So volt deposit really allows you to explore a sort of multi-dimensional space, and I would argue more rapidly get to a ideal material. Now, I was touching upon it a little bit there, but there's a sort of area of electrocatalysts, and it's the materials there are called sort of multinary. You can have binary materials, tertiary materials. Binary is obviously 2, tertiary is obviously 3. But you can have 4 combinations and 5 combinations. Now the problem is that people would like to explore these materials, but once you have sort of the capability of having a material that's made up, let's say, from 5 elements, you have the possibility of having to go through more than 2 million materials. So unless you automate it, and I think automation probably comes in several places, you have to be able to automate the actual generation of the experiments themselves. Then you have to automate the experiments themselves, and then you have to automate the analysis, let's say, themselves. And it's really only in this modern age where we actually have robots, we have AI, we have cloud computing, that we could genuinely do this kind of large-scale effort to find new materials. So I think that volt deposit is helping to solve problems in multinary discovery, or the discovery of multinary materials. And I think that those multinary materials can actually be an example of high entropy alloys. So high entropy alloys are materials that kind of have a application potentially, as I say, sort of in batteries, in fuel cells, in electrolyzers. But it's really linked to earlier on. If you want to discover these new materials, with the number of combinations of permutations available, both through the elements themselves, but also through the processes that place those elements, for example, on the electrodes, it's too simply many experiments to have to do. But of course, with something like the volt deposit, it's a robotic system. It can move through between solutions in an automated manner. We could do depositions, we could do washes, and then we can do tests. So it really, I think, helps to explore this space in a much more efficient manner. And then it does solve that problem that even though you're doing the synthesis and you're generating the data in an automated fashion, you then do have to process that data, and having that kind of link up to the cloud and be able to process that data in the cloud, which Volt Deposit can do, I think that really speeds up the entire process. I did see a comment the other day that somebody said that the place for humans in the future, in technology of the future, is to go from 0 to 1. What they mean by that is that AI will be an assistant for us. So when we want to kind of go from 1 to 10, AI can actually be real help to us. But that 0 to 1 is that insight, that sort of magic moment. So I think humans will be the 0 to 1 guys. And I think answer the question, what should Volt Deposit be working on? That's a 0 to 1 question. And then how good the materials are is a kind of a 1 to 10 question. I think that's when Volt Deposit would actually kick in. So I think clearly there's still a place for people. So let me just do a wrap up on our news for this week. So every Thursday we do our webinar. So if you've got any technical questions, we will do it at 8 a.m. London time. This week we have been holding a workshop. So these workshops do happen every first week in Norway and every second week in Coventry. And we have put out a lot of sort of articles this week around Volt Deposit. And Volt Deposit really is a sort of high throughput combinatorial robotic system driven by AI that can do electrochemical depositions, but then it can also do analysis, and then it can also crunch its own data as well. So if you have any questions as EP, please don't hesitate to reach out to us. Okay, thanks very much.